In this quick tip, we want to describe how to solve similar right triangles, making use of our knowledge of trigonometry. Just a quick reminder, two triangles are similar if they have the same shape, but not necessarily the same size. Now, for two triangles to have the same shape, that means that their corresponding angles have equal measure. That is the case in this diagram here, because the same two lines are forming the angle. This angle here and this angle here must have the same measure. And because they're both right angles, those two angles have the same measure. And then we know that if we wanted to compute the measure of this, we could take 180 minus the sum of those two, which is the same as the sum of those two. So whether you so the calculation you do to compute the measure of this angle, and this angle is the same, therefore those two have the same measure. So these two triangles are similar, and we would like to be able to compute the length of each side of each of these angles, each of these triangles, as well as the measure of their angles. Well, why don't we start with this one we know something about, and we can compute this third side, and then we can also compute these two angles. Now, we have options here. We could use a trigonometric function, but we could also use the Pythagorean theorem on this, since that's a right angle. So let's do that. C squared is equal to 8.6 squared plus 6.2 squared. And we'll compute this sum, and then we'll take its square root in order to get C. And we get 10.60. Now we're going to round off, so this becomes a 9 here, 6019. All right, so we have all three sides now. And we would like to be able to get one of these two angles. Let's call this one theta, and of course this is also theta here. The tangent of theta is opposite over adjacent, and therefore the inverse tangent of 8.6 over 6.2 is the measure of theta. This we do with our calculator. And we get about 54.2110 degrees. Now that's theta. Let's call this one alpha. Alpha is easiest to get by subtraction. We know that that's a 90, so these two must add up to be 90. And 90 degrees we've used up the measure of theta, 54.2, etc. So we can take 90 minus 54.211, and we have 35.789. And that's accurate to the zero there, so this one is accurate to the zero as well. So we now have all three angles and all three sides of one of the triangles, and we have one side of one of the other triangles. So now we can start computing by using ratios. The length of this side compared to the length of this side. So we're sticking within a triangle here, long leg compared to short leg, and then we'll do the same thing, long leg compared to short leg, and we'll give that a name. And now we simply want to solve this. Some people like to think of this as cross-multiplying. Others like to think of it as just multiplying through by both 6.2 and y. However you do it, you'll get this. And then we divide through by the 8.6. and we would like to keep several decimal places. So get 2.8837. And that's our distance here. Now we have the option of using calculation from similar triangles, or we could use the Pythagorean theorem since we know these two sides of this right triangle. Why don't we go ahead and use the Pythagorean theorem? We need to give this a name. I've already used up C up here, so let's call this D. D squared is equal to this length squared plus this length squared, and that allows us to compute D with our calculator. It's simply the square root of that sum. So you have the square root of 2.8837 squared plus 4 squared. There we go. And we get 4.9311. And that's our length D. Well, we have Y and D both. We have these angles because they're the same as the angles in that triangle, and we have all the sides and angles up here as well. So we have solved both triangles in this diagram, and we're making use of both properties of right triangle, of some trig function, and the Pythagorean theorem.